Hey, what does give me 5 mean?
Means be quiet and pay attention.
Fantastic. Okay, so that's my attention together, guys. So whenever I need to get a hold of you throughout the lesson, because we're going to be doing things, I'm going to need to be able to get a hold of you. I'm going to say, give me 5. And so that gives you 5 seconds to stop what you're doing, to get your eyes and ears on me, and to get ready to listen to the directions that I'm giving to you. I'm really excited to be here today to teach you some math. I'm going to talk a little bit more about that for you. I have a focus up on the screens. I just have to keep it going, otherwise it shuts it off. So if you could, take those 3 problems on a sheet of scratch paper and work those out, and then we'll talk about them here a little bit. And 5-minute focus is done independently, which means by yourself. I know you're sitting at tables. We'll have an opportunity to talk, but right now this is for your own work. So please do those 3 problems. Square root of 25 is the first one. I'm sorry I cannot get that advertisement to shut off. So again, this was independent work. Should be on a sheet of scratch paper. Please write these 3 problems down quickly because you never know when we're going to lose this screen for some reason. Okay? So anytime you try something new, sometimes you have to work out the kinks. Okay. Remember, this is independent work, so I should hear no talking right now. This is for you to be thinking about your mathematics and answering these 3 questions. This is a level 0 talking. Thank you. Please write these 3 problems down immediately. It'll probably clear off here in the next 5 or 10 seconds. So please jot these 3 problems down and then begin working on them. Again, the first one is the square root of 25. Number 2 is the cubed root of 64. And number 3 is 3x plus 5 equals 29. Nick, do you have a question?
No.
Okay. Nice job. Thank you for getting to work quietly. Thank you. Thank you for following the expectations. Good. Try to solve them. Go ahead and try to solve them now. Make sure you're trying to solve them. Thank you for working quietly. Thank you. Yeah. Okay, remember square root is what times itself equals that number that's underneath. Okay? So what times itself equals 25? That's got to be times itself, so it's the same number times the same number. Think about that. Thank you for working quietly. I appreciate it. Thank you. Okay, this is for a piece of scratch paper, okay? Thanks for writing them down on here. We're going to do them on a sheet of scratch paper for me, okay? Yes, do you have a question?
I thought I had a pencil.
Gotcha. You don't have a pencil? Can you borrow a pencil from somebody? You want to borrow a pen? Okay. Yeah, bet. Thank you. Do you have any questions? Thanks for getting to work. Give you about another 30 seconds to finish that up, guys, and then we'll talk about it. Okay, give me 5, 3, 2, 1. Thank you so much. Make sure your eyes and ears are on me, please. Thank you very much. Okay, so let's talk a little bit about our expectations today. Okay, I know that obviously I'm coming in here. This is a one-time lesson, but if this were my classroom, these are my expectations for today. I really believe in the 3 pillars of our PBIS system, which is being safe, being responsible, and being respectful. So those are the kind of language that I'll be talking to you. If you're not acting in the way that I want you to, you're going to be hearing me talk about being respectful, being responsible, and being safe. But underneath that, I kind of have 3 rules that I've always lived by, and I'll probably refer to those as well that fit right along with that, is to love, serve, and care. And so if everything we do today, we're caring about ourselves and we're caring about others, and everything we're doing today, we're serving ourselves and serving others, and also loving each other and loving ourselves. Now, I know that love, a lot of people think that it has to be smoochy, smoochy, huggy, kissy, but that's not the only type of love, okay? And so those are the things I'm really going to be emphasizing today as we work on mathematics together. I'm hoping that today, by the end of today, you will learn how to identify the parts of a right triangle and be able to find the missing piece of a right triangle using the Pythagorean theorem. So if we know 2 of the sides of a right triangle, you will know at the end of today how to find that 3rd side using the Pythagorean theorem. So those are our 2 learning goals today. Identify the parts of a right triangle, and then number 2, be able to use Pythagorean theorem to find the length of the 3rd side and then apply it in a real life scenario. Okay, our social goal today is to, again, care for others, care for ourselves, serve others and serve ourselves, and then show love for each other and for ourselves. Okay, so the first problem, square root of 25. You've been talking about square roots in math class. Can anybody talk to me about how, what the answer is and then how you find her? What does it mean to be a square root of something? So square root of 25. Anybody? Yeah. Okay, it's 5. So if you look up here, I'll be taking notes here if you want to follow along with your notes up on the board. The square root of 25 is indeed 5. Okay, that is one of the answers. Is there any other answers for the square root of 25? Yeah? You don't think so? Okay. Anybody know of another answer? Frank? Negative 5. So it's plus or minus 5. Because if we take 5 times 5, that's 25. If we take negative 5 times negative 5, that's also what? 25. So a square root actually has 2 solutions. Now, in most applications, what answer are we going to be worried about? The positive. In most applications that we're going to talk about in mathematics, we're only going to be talking about the positive solution. And for today, in our application, we're only going to be looking at the positive solution. But I want you to know that there is indeed 2 solutions to the square root of 25. Okay? Let's go on to the next one. Any questions? Square root of 25. Anybody have any questions about that? Plus or minus 5. Okay, the next one is the cubed root of 64. I believe you talked about that yesterday. Is that right, Mr. Atwell?
Yeah.
Okay. Okay. Cube root of 64. Anybody have an answer for the cube root of 64? Yeah.
4.
4. How did you get? How is it 4?
If you take 4 times 4 times 4 equals 64.
Okay. Can you explain that to somebody that is just learning about cubed roots? How you know that it's 4 times 4 times 4?
I'd rather not.
Anybody can explain that? So if I didn't know what a cubed root was, how would you explain it to somebody else? Dagan?
It's pretty much you take the number and you. No idea.
No idea? Okay, that's all right. That's all right. No idea? Okay. Well, the 3 stands for cubed, right? The cubed root. So it's a number that's cubed that gets you that number that's inside, that's 64. So what number cubed equals 64? And that cubed means to multiply itself 3 times, right? 4 times 4 times 4. And indeed, 4 times 4 times 4 is 64. Now, today's lesson, we're not going to be using cubed roots, okay? But I know that's something that we talked about yesterday, and I wanted to make sure that you understood the concept. Okay, the next one is a simple equation. Can somebody tell me what the equation was again?
3x plus 5 equals 29.
3x plus 5 equals 29?
Yep.
Thank you. Okay, simple equation. What's the first step? Kobe, what's the first step to solving this?
I know.
Okay, what do you think it might be, Kobe? Okay, we'll phone a friend. Jonica?
Take 5 away from it.
Minus 5. Okay? So we have to subtract 5 in order to balance out the equation. What I do to one side, I have to do to the other. Give me 5. 4, 3, 2. Well, hey, one of the things I'm really passionate about, guys, is that when I'm talking and I'm teaching, that you're focused. Okay, I'm really passionate about that because that's called being respectful. So let's make sure we get through these notes, and if you don't know how to do it, this is an opportunity for you to learn how to do it because we're going to have to be able to solve equations today as part of our lesson. So this is a prerequisite skill. Okay, so we need to be able to have this. So please follow along here. If you're unsure how to solve this equation, you're going to need to by the end of today because that's part of our lesson today. So if we subtract 5 because the equation had plus 5, in order to get the 5 over to the other side, what I do to one side I have to do to the other. So I end up with 3x equals 24. Okay, now I got to get rid of that 3. How do I get rid of that 3 and get x by itself? Yes?
When you use whatever times 3 equals 24.
Okay, so the answer is whatever times 3 is 24. So how do I find that out? What operation can I use to undo that multiplication over there? Yes? Division. What would I divide by? 3 divided by 3, and then what I do to one side I have to do to the other. So I'm going to divide both sides of the equation by 3. Please mark that down in your notes. And then x would equal 8. Very good. Give me a 1 through 3 on that, which this is what I mean by that. It's a formative assessment. A 3 means that you're a rock star and you completely understand everything I just talked about, those 3 problems. 2 means you're kind of, yeah, I understood some of it. And a 1 means I absolutely don't have a clue of what you're talking about. Let me see with your hands where you're at. Please be honest. Okay, it's okay. I didn't say it. I said to show me with your hands. Nick, where are you at? 1, 2, or 3? 1, 2, or 3? Okay. All right. Okay, put your hands down. Nick, you marked yourself as a 2. So what's something that we need to talk about to go further in our learning? Was it the equation or was it the square roots?
The square roots.
The square roots. Okay, what are you struggling with? What would your question be to me that we maybe need to go over? Because there were several of us that had 2s.
You asked, do I struggle with the square roots or the equations?
Which one do you have problems with, the square roots or the equation?
I have more problems with the equations.
The equations, okay. Let's practice another one. Everybody right now, let's clear your boards. Let's go ahead and get your markers out. Clear your space so we can get on a marker board. Let's go over another equation. Okay, let's do one more together so that way we can go on to the Pythagorean theorem. Okay, give me 5. Awesome. Okay, everybody's got a marker. Anybody not have a marker?
There was a green one here, but I don't know.
I think I have it.
Can I erase the number on the table?
Yep, that's fine. Okay, here's your equation I want you to do. Do 4x plus 6 equals 18. Everybody right now, try to do it on your own. I'm going to give you a minute to do that. Okay, right now, on your own, try to do it on your own. 4x plus 6 equals 18.
What's the first step? What do we do on the last one? Look at your notes. On this last one, what do we do? We had 3x plus 5 equals 29. First step was to minus 6. Very good. work. Okay, let's see if I can find you another one.
I got it.
Do you have an extra marker over here?
I got it.
Copy.
You copied.
Okay, give me 5, 4, 3, 2. First of all, I just want to say right there, that was excellent. I asked you to be independent, and all of you guys were working independently and trying to. I really appreciate that. So thank you so much. When I ask you to do something, I just really appreciate it when you cooperate. Now, what I want you to do is at your table, I want you to take a look at everybody's, and I want you to work through it together. If you guys got different answers or if somebody needs some help, talk with each other on it. Go, I'll give you 1 minute.
Somebody raised mine.
He raised mine,
So going forward, guys, what we need to make sure is leave each other's property alone, right?
Yeah.
So, okay. All right, so let's talk about it. Let's talk about the equation.
It's minus I did divide it, but I guess.
Like, I got this 4 and 12, is that right?
What's 12 divided by 4? Yeah, that's right.
Oh, 12 divided by 4?
Yeah,
and
because
then
you're
that's
dividing.
the answer?
Yeah, that's your answer.
And then 12 divided by 4 and that's the answer?
Yeah.
Okay, now
Yep, you got it. Yep. Are you guys talking over here? Okay, so are you talking to him? Nick, did you get it? Where's your work at, buddy?
I've been working with him.
we
Okay,
don't-
so did I ask you to work with him?
we don't have a marker.
No. Oh, you don't have a marker? Okay. So let me see if I can find you a marker, okay?
Nothing follows.
Hey, Nick. Earlier I asked if everybody had a marker, and
I must not have heard
you didn't raise your. So can we pay attention? I appreciate it. Thanks. 5, 4, 3, 2, 1. Awesome job. I really heard a lot of collaboration there. I also heard you guys talking about the equation in math and what the next steps were. So what I want you to do is tell me, Jordan, what's the first step? What do we do here?
You do. You gotta do 6, minus 6.
You got a minus 6, yep. So because we have plus 6 there, we got to get those whole numbers all on the same side. So we subtract 6 from both sides.
And then you do, it gets 12. And then you gotta do 4 times 4, and it gets,
Just wait 1 second. So the first step was to minus 6. Does anybody have any questions about subtracting 6 from both sides? Anybody have any questions about that? Okay, good. So we got the first step down. That's awesome. So then we have the equation 4x equals 12. Now we have that multiplication over here, that 4 times the x. So how do I undo multiplication? We had the answer from over here earlier. What do we do? Division, yeah. So what do we have to divide by, Dagan? 4. By 4. So we have to divide both sides now by that 4. And you get 3. Thanks, Jordan. So x equals, and I'm sorry that my writing doesn't look very good. My writing in real life is better than what I'm showing here, I promise you. So, ladies and gentlemen, right up here. Side conversations, you stop. Does anybody have any questions about dividing by 4? Okay. Please get out your notebooks. Be ready to take notes here in 30 seconds. $15 seconds left. Have your notebooks out. As you're doing that, I will tell you that today, let me show you a little bit about how I do things. Give me 5. 2, 1. Okay, let me tell you a little bit about how I do things, because notes are really, really important to me. Because when you're taking the notes, that means you're following along and you're trying to make the connections to the brain. Okay? Also, notes are really important to you. Why? Because you can use them on your quizzes, you can use them on your tests, you can use them on anything that we do going forward. Okay? I'm not trying to see if you can memorize things. I want you to be able to apply the things that we're talking about in math. Okay, so today you're going to have a quiz at the end of the day. That quiz will decide how much homework you have. If you get 100% on the quiz, you have 0 homework. If you miss 1 problem on the quiz, you'll have a couple problems of homework that tie directly to the skill that you missed on the quiz. So again, on your quiz, you can use your notes. So it's advantageous for you to use your notes. So please take good notes. Okay, Pythagorean theorem.
Do we write this down?
It is something I'm writing down, so what do you think?
Yes.
I would agree with you. Okay, so Pythagorean. There was a guy named Pythagoras way back when, a long time ago in history, that said, hey, look at this interesting relationship that only seems to happen between right triangles. Okay, so this Pythagorean theorem only works for right triangles. It doesn't work for obtuse. It does not work for acute triangles. It only works for right triangles. A right triangle has a 90-degree angle. That's what makes it a right triangle. So this Pythagoras guy says, hey, wow, every right triangle I come across, this relationship seems to always exist between the legs of a right triangle and the hypotenuse. These guys right here that I just put a line by are the legs. Probably want to identify that. Since I'm having some penmanship issues, I'm just asking for you to identify those as legs. I called them L for legs. L-E-G-S, your legs. The legs of a right triangle create the right angle. Okay? Those two sides hinge at the right angle, as you can see here on the screen where I put the little box. This side over here, I'm going to put an X beside it, is called the hypotenuse. And I'm going to try to write that out for you. Hypotenuse. Hypotenuse. Remembering that one of the things that you're going to be asked in the quiz is to simply identify the parts. Can you identify the legs? And can you identify the hypotenuse?
Did you ruin my notes?
Anybody have any questions so far about the parts of a right triangle? You have a question?
No.
Okay. If you ask a question, there's no silly questions, all right? Please ask. So, this is the identification of the right triangle. The two legs and the hypotenuse. Well, how do I know which side is the hypotenuse? If I look at that diagram, it will always have a relationship to something else. Can anybody identify what that is? There will always be something that's going to happen, a relationship between another part of the the triangle, and the hypotenuse. Talk about it at your table for 15 seconds. How can we identify that?
Aiden, yes it is.
Talk about it, please.
I think is it the side piece?
Yeah.
5 more seconds. Give me 5, 4, 3, 2, 1, 0. Yes?
So what is the height of the whatever? Is that like the actual triangle or is that
Okay, good question. Did everybody hear her question?
No.
Okay. She just asked, what is the Pythagorean? Like, what's the part of it? Pythagoras was the guy who developed this relationship. And I'm going to be talking to you about what we call the Pythagorean theorem here in a minute. We're building up to that. But in order to talk about the Pythagorean theorem, we have to understand the relationships of the parts of a right triangle and how he described them. Okay? So Pythagorean is not the right triangle. It's a guy who developed this theory, and that theorem, for the relationships of sides of a right triangle. Okay. So, going back to my last question. If you look here at the diagram, okay, everybody look at the TVs that you have in front of you. There's 5 of them. The X and the little square in the triangle, the right angle, are always going to be opposite of each other. Okay? So the hypotenuse will always be straight across from the right angle. Okay? The right angle.
So the hypotenuse is the x.
The hypotenuse is the x, exactly. Okay? Now stay with me here on some notes, guys, because I know that we have to go through these notes in order to be able to kind of dig into it a little bit. And I know this is probably the kind of the dullest part of the lesson. So please stay with me. I got a question for you that I want you to talk about at your tables. Which side in a right triangle will be the longest, the hypotenuse or one of the legs? Talk about it at your table. Why? Why is it the hypotenuse? Because why? Because why is important?
I don't know.
Talk about it at your table. What do you guys think it is?
Hypotenuse.
Why?
Because it takes 2 45s to make 90-degree angle. So then the other angle has to equal 90.
Together, combined.
Yeah.
Why? Why do we know that?
Because every triangle equals 180 degrees.
Awesome. Good job. Okay, give me 5, 4, 3, 2, 1, 0. Jadalyn? What's the give me 5 procedure?
I'm sorry, I was explaining my answer.
What's the give me 5 procedure, Jadalyn?
Can't never find that very quiet.
Can you follow that in the future for me? I appreciate that. Thank you so much. So, let me get this back on here. People, when I was walking around, were telling me that the hypotenuse will always be the longest side. And that is absolutely right. Okay? And there's a reason for that. And I'm going to speed it up a little bit because we got to get going here today. The 90-degree angle is going to be the biggest angle in the triangle. Because can I have 2 angles of 90 degrees in the same triangle? Can I? Can I have 2 90-degree angles in a triangle? No. How many total degrees are in a triangle? 180. So I know that the 2 other angles have to be smaller than 90. It might be 90, 89, and 1. That's possible. And so if we think about a hinge opening up, when I have my biggest angle is 90, that means the side opposite that will always be the longest side. Okay? Any questions about which side's the longest? All right, so with that being said, take your notes. Keep taking your notes here. Here is what we call the Pythagorean theorem. He said, because of this relationship in right triangles, we know that a squared plus b squared will always equal c squared. And I'm going to explain that in just a little bit. He says that in right triangles, a squared plus b squared equals c squared. Okay? That's called an equation, or a formula, if you will. Let me identify some parts of this equation. Stay with me. A and B will always be the legs, and it doesn't matter which leg you name A and which leg you name B. But both of the legs will be A and B. So, underneath this line on my notes, I'm going to put A, and I'm going to put B for the other one. Does it matter which one I label A and which one I label B? No, it don't. Okay? I just know that A and B are the 2 smallest sides. They're the legs. And the longest side, which is called what? The hypotenuse is going to be what letter do you think, guys? C. There you go. And so he said, every time, no matter what, every time, he just kept doing it over and over and over and over with all kinds of examples, that when I take one of the legs and I square it, and I take the length of the other leg and I square it, and I add those two together, it always equals the square of the hypotenuse. Okay? It always does. He did it over and over, and that's why he came up with the Pythagorean theorem. Okay? So let's look at how this can be utilized in an example. Okay? So I'm going to clear this real quick, guys. And I think it'll all start making sense to you. What's going on here? Oops, I didn't mean to do that. Okay. If I have a triangle, and what kind of triangle do I have to have? Right triangle, which means I have what kind of angle? Right angle. Which is how many degrees? 90 degrees. How do I know that it's a 90-degree angle? I put a little box in it. Good, perfect. Okay, so if I have this example, I know that the height of this triangle is 5. And I know that the height, or the length of this leg over here is 4. And I want to figure out what the distance is for this. Okay, think about it this way. Let's say that I'm building a wall, and I need to put a support on it. And I know that my stake in the ground is 4 feet from the base of the wall, and the wall where I want to anchor to is 5 feet up. I need to know how long my board needs to be, and I don't want to have to cut it twice. I don't want to have to buy the wrong board or get one too long or get one too short. I want to know what the length of that board needs to be. Okay? Because I don't want to have to run Menards twice when I can do it once. So, looking at my Pythagorean theorem, I can find what that side is using math instead of measuring. Okay, yeah, we could get out our tape measures, we could measure, or we could use math. Okay, so think about your formula. A squared plus, say it out loud, B squared equals C squared. Okay, what's one value, Tanner, I could put in for A? Tanner, what's one value I can put in for A? 5. How many of you agree that I could use 5 for A? Raise your hand if you agree. Okay, you could use, how many disagree that you can't use 5 for A? So nobody disagrees. Can I use something else for A? What else can I use? 4. Because remember, guys, does it matter which leg is A or B?
No, sir.
No. But I notice in my formula, A and B will always be the legs. So it doesn't matter. But just for simple sake, we started with it. Let's put 5 in for A, and we're going to plug in 4 in for B. Okay. Oops. So 5 squared plus 4 squared. Make sure you're taking your notes because it's going to be on your quiz. There's going to be a problem just like this, and you can get it right. You can also use it on your final test at the end of the unit. Because you know what? In real life, if I'm out on the job and I don't know how to do something, what do?
Wait, I'm just kidding.
I look it up, right? I look it up, and then I have to apply what I'm reading. Okay? It's the same thing here. You're going to have notes that you can use to apply. I'm not trying, it's no I gotcha, no surprises on the quiz, guys. No surprise, no I gotcha. So, let's calculate this out. So did anybody have any questions about how we set up the equation to solve for C? No questions? Good. What's 5 squared? 5 times 5 is? 25. Plus 4 squared is? 16. Because 4 squared is 4 times 4 equals C squared. How much time do I have left? A minute? Okay. 25 plus 16 is 41 equals C squared. Now here's where that square root comes in. In order to solve for C and get C by itself, guys, follow one more step here. I have to take the square root of C squared to get C. Because c times c is what? C squared. So if I take the square root, I end up with c, and this one's an odd value. What is it rounded to the nearest tenth? 6.5. 6.5? 6.4?
Dang it, well, I was close. You were close, yeah.
So rounded to the nearest tenth, c, the length of that board I would need is 6.4. Here's what I need you to do. Here's what I need you to do. Now, listen up here. Stay with me, Frank. Okay. Now, you guys have been a great group. I know there's a lot of notes today because there's a lot of things we got to get through. Tomorrow, what we're going to do is going to continue this discussion. At the end of that discussion, there's going to be a quiz. That quiz will decide what your homework is. So have a great, great evening and afternoon. See you tomorrow.